Alright, today we're going to look at very important laws or properties of logarithms. In the last lecture we introduced what a logarithm was, and I hope that you remember that a logarithm is an exponent. If you don't remember anything at all, please remember a logarithm is an exponent or a power. Again, the logarithm is the exponent or power on the base. And this letter A is the base, right? Being a positive number not equal to 1. The logarithm is the power on the base, right? The exponent we need to raise the base to in order to get the value of the input of the logarithm. And so with that, we have some important properties. And these properties of logarithms we're going to be using in varieties of ways. In this course, we will use properties of logarithms in helping us to solve logarithmic equations. Later on, when you go on to calculus, these properties of logarithms come into play in different settings and greatly ease sometimes complicated calculations. Logarithms actually were invented or used, I guess, hundreds of years ago initially to deal with easing complex calculations. So let me explain how that works. First of all, here's the properties of logarithms. And so this is the logarithm base A, and A, so it could be any logarithm. It could be log base 2, log base a half, log base E. Remember log base E, the natural logarithm is ln. That's what we use for that special one. And then log base 10 is usually just written log. But any of those, if I have a log of a product of two quantities, so x and y here, both are positive quantities, and we have to have that, remember, because the domain of the logarithmic functions was all real numbers greater than 0. And so if I have the log basically of a product, then that becomes the sum of the logarithms. Now, why is that the case? Well, if I'm looking at a product, let's suppose x is maybe a, I don't know, just make this up, a to the 5th power, and y is equal to a to the 3rd power. Okay, and so what's this mean? This means that the log base a of x is what? Remember, the logarithm is the exponent or power on the base. The base is a, needed to get x. Well, a to what power gives me x? 5. So that, do you understand? The logarithm is that exponent on that base. Over here, this tells me log base a of y is what? What's the exponent on a needed to get y here? 3. Okay, so what this is saying over here for property 1 then is, what would the log base a of x times y be? Well, what is x times y? That's going to be what? X is a to the 5th, and y is a to the 3rd. What do I do when I multiply like bases to different powers? What do I do with those powers? What do I do with those exponents? What do I do with those logarithms? We add them. 5 plus 3, right? Which is, of course, to the 8th power. So this tells me, notice, that the log base a of x plus y, or x times y, excuse me, is the sum of the logs, right? The sum of the logs, log base a of x, which is 5, plus log base a of y, which is 3. Right? In this case, it's equal to, right, 8. Right? And that's how we're getting this, right, this property. It's simply because logarithms are exponents. And what do we do when we multiply like bases? What do we do with their exponents? We add them. In the same way, what do we do if I take the logarithm of a quotient? If I'm dividing like bases to different powers, what do we do with those powers? We subtract them, remember? And here it says, what if I have log base a of some number raised to another power? Right? What do I do with the exponents there? N is an exponent, the logarithm is an exponent. We multiply, don't we? Remember? So like if I have a to the 5th and then I raise that to the 2nd power, that's a to what? 5 times 2, a to the 10th power. Right? We multiply. And so all these logarithmic properties just come from the properties of exponents. But the neat thing is, if we're dealing with a product, we can find the product by actually finding the logarithm. And notice in finding the logarithm, we're changing a problem where we're multiplying to adding. In general, addition is easier than multiplication. Here we change a division problem into subtraction. Again, division more complicated in general than subtraction. And here we're doing exponentiation, x to some power. Now we're doing multiplication. So these ease the calculation. And in the day and age of before calculators, when you were multiplying very big numbers, x and y together, it was much easier actually to deal with their logarithms to some base, say base 10 or base e or whatever it is, and then add the logarithms. Now someone did have to construct back then these huge books that were, you know, tables of logarithms. Someone calculated the log base a, or whatever, log base 10 or whatever, for all sorts of numbers. so someone spent a lot of time cranking those things out, but then when they completed that book, people could use it and do these calculations very quickly. Right? So they would actually add the logarithms, and once they get that, they would just then do the simple, hopefully relatively simple power of raising the base to that power. And they can use the table of logarithms that they had to do that as well. So at any rate, that's where they came out of. That's where it was used hundreds of years ago. Today, of course, we have technology like calculators and stuff to do a lot of things for us, but it's still very useful to know these properties. And as I said, we'll be using them to help us with solving equations. Okay, so the two things I want to look at are expanding and condensing logarithmic expressions using these properties. Okay, so we're going to use these properties to rewrite, in this case, to do the expanding, to write the expression in a form with no logarithm of a product, quotient, or power. In other words, if we have a product, quotient, or power, we want to expand it, so to speak, turn it into addition, subtraction, or multiplication. And so we're going to rewrite as a multiple of logarithms of a single quantity. Okay, evaluate logarithms where possible. Okay, let's take a look at the first problem then. So log base 2 of what? So this is important to note that all this stuff is inside the log base 2 function. Essentially the question could be, what's the power, what is this answer? It's the power of 2 needed to get this expression in the brackets. Okay, and we're not going to answer that. We're just going to take this expression and expand it. And if you notice in here, I have a product of three things. Let me underline the three things. I've got 16, I've got x cubed, and I've got x minus 1. So what I'm going to use is I'm going to use property number 1, and just to emphasize that, I'll put the number 1 up here, because I have the log of a product. And here I've got two things. If you had product of three things, you would just add that logarithm for that expression. So you just keep adding logarithms if you have more than two things multiplied. Here I have three things, so this would be log, and here the base is 2, of 16 plus log base 2 of x cubed plus log base 2 of x minus 1. Right? So that's using property 1. Okay. Now, before we use any more other properties, I want to just look at this logarithm, because the instructions were to evaluate logarithms. Ooh, that's wrong. Were. I need a where. Where possible. Sorry. Where possible. All right. So what is the answer here? What's the power? What log base 2 of 16? What's the power or exponent on 2 needed to get 16? 2 to what power equals 16? I want you to come up with that. 2 to what power equals 16? Answer? 4. If you said 4, you get a big pat on the back. That is awesome. 2 to the 4th power is 16, so log base 2 is 16. Now, the remaining expressions can be further expanded, we say, because we want to write these expressions in the form with no logarithm of a product, quotient, or power. And here we have a power, right? And so notice by property 3, I can change. Essentially what happens here, if you think about it, is this power kind of comes down in front. This is essentially the net effect of this. So if I have a log base a of x to some power, it becomes that power n times the logarithm. So here n is 3. So I'm going to rewrite by property 3. This is just 4, right? This is just 4. Plus what? This 3 comes down essentially 3 times log base 2 of x. Now, what about this thing? Can I expand this anything? Can I distribute? Hey, can I just do log base 2 of x minus log base 2 of 1? Can I distribute here? No. There's not multiplication going on here. This is not log base 2 times x minus 1. This is the name of a function. This is like f of x minus 1. You can't do that. You're plugging x minus 1 into the logarithmic function. And notice that that is not this property here. This is the difference of logarithms. Log base a of something minus log base a of something, right? This is not log base 2 of something minus log base 2 of something. This is log base 2 of something. In parentheses, we have subtraction going on. That cannot be further simplified by any of these properties, right? It's a subtraction, right, inside the logarithm. We can expand multiplication, division, or exponents, not subtraction or addition. Does that make sense? So this cannot be any further expanded, so don't force the issue there, that's it. This is as expanded as we can get. And that's what we mean by expanding as much as possible. Now this technique of expanding logarithmic expressions like this, very helpful later on in calculus when we're doing things like, we'll learn about taking a derivative of a function, and this will be very important to make life a little bit easier on us. Okay. Take a look at this one. All right. Here I have log, whoa, what's the base? There's no base there. What's going on? Log what? I hope you realize that's what? Base 10. This is the common logarithm. If there's no base written, it's always base 10. Log of x squared divided by that. So I'm going to use property what? 2. If I have the division, right, of two values, it's the difference of their logs. So it's the log of what? The top, very important, minus the log of the bottom. Has to be in that order. Log of the top minus log of the bottom. Okay. Now when I look at this, I want to first look at this logarithm over here. I have a log of a product, right? And so log of product is what? The sum of the logs by property 1. So I'm going to make use of property 1 first. So I'm not going to affect this first one. We'll come back to that. We'll do that one in a minute. All right. And then I want to use the property here. Now, I'm going to do something incorrect, and I'm going to see if you can catch this. So that's a minus sign there. Now, the log of a product, we say, is the sum of the logs. Okay. All right. I'm going to write this out. So log, sum of the logs. Log of what? I've got y times z cubed, right? So that's log of y plus log of z cubed, right? That plus that. Okay. Made use of that property. But I have an error here. This is incorrect as written. Some of you, I hope, know what's going on. What do I need to do to correct this? What do I need to do to make this correct? Minus what? This whole thing. This whole thing is this. Minus this whole thing. What do I need to do? I hope you're saying put a parentheses around it. Or that you're saying what? That we have to distribute this negative 1 through both terms. Do you see what happens there? All right, so the minus the log, so I have to use that property to write it as the sum of logarithms, but then I subtract, right, which means I'm going to, yeah, multiply both things by negative 1, distribute that negative 1 over the sum. Let's just do that. So that's a common mistake there, minus log z cubed. And now I can do one last thing. So this one, right, log of x squared, and this one here, log of z cubed, I can use property number 3, remember, to bring that power down to make it a multiple of the logarithm. So this will be 2 times log of x minus log of y, and then bring the 3 down, 3 times log of z. We can put parentheses around the x, y, and z here, but again, usually it's written without it, parentheses, but this really is log of x. It's not log times x. It doesn't make any sense. Log of x, right? The logarithm of x. The power on the base 10 needed to get x. That's what log x is. Okay. This is our answer. This is as much as we can expand this. Now I went through all the process, right, using the different properties. I numbered here. Property 1, property 3. But I want you to notice that you can have also gotten there a little bit differently. So this is a step-by-step process. But another way I could have thought about this is when you look at this, I can rewrite what I'm taking the logarithm of as follows. I've got x squared, and then divided by y or times 1 over y. But what's 1 over y? That's y to the negative 1 power. 1 over z cubed, z to what? Negative 3 power. So this is another way down here of writing the same expression. All right? And then I can go right to property 1 because I now have a product of three things and write this as log of x squared plus log of z to the negative 1 plus log of z to the negative 3. And then by property 3, I'm going to rewrite here. Right? Bring the powers down. 2 log x, negative 1 minus log z, negative 3 minus 3 log z. You see how that happens? And so you can almost see, because these y and z variables are in the denominator, notice the coefficient in front of them becomes negative because of that, because of these negative exponents, the negative logarithms, if you will. And the numerator, of course, being x squared means the coefficient is positive. So I can actually look at this expression and go right to this boxed expression rather. But again, as you're doing these, it's helpful to go through each step and see how that works. Okay, let's try one more. Now this one looks a little different. A couple things. First of all, ln. What's ln? That's log base what? What's the base in that case? E, right? Hope you're saying E. Log base E. Now, log base E square root. We haven't talked about any property of logarithm involving square root. We have products, quotients, and powers, but what do we realize, I hope? It's not actually a problem, because the square root of something is the same as what? All that stuff, 7p cubed q to what power? 1/2. So it's really a power, right? And so that third property kicks in first here. I can bring this 1/2 down. Okay. And now I have the logarithm of a product of three things, so I can use property number 1. Okay, and here I got to be careful, right? Again, 1/2 times all this stuff, so what do I need to make sure I do? In parentheses, or I'm going to put brackets here, natural log 7 plus natural log p cubed plus natural log of q. So I need to make sure this 1/2 gets distributed through. Okay, well, property number 3 says what about this? Natural log of p cubed. That's 3 times the natural log of p. Right, by number 3. And so if I distribute now this 1/2 through, right, to all three terms, then what do we get? Oh, by the way, natural log of 7, remember we said to evaluate logarithms if you can. I don't know the power of e needed to get 7. E to what power equals 7? It's not an easy one. So we're just going to leave that as just ln of 7, natural log of 7. Plus 1/2 times 3 is 3/2 natural log of p plus 1/2 natural log q. And there's our answer, fully expanded. Now, I could have also got that, let me just say, another way of getting to this result is if I had gone ahead before using that property 3 and just say, well, a product raised to an exponent, I can distribute that power, right? So this would be 7 to the 1/2, p what? Cubed times 1/2, right? Because I multiply exponents, p cubed to the 1/2 power is 3 times 1/2 is 3/2, and then q to the 1/2, right? And then you can see right away what's going to happen. Then I can write this as, you know, natural log of 7 to the 1/2 plus natural log of p to the 3/2 plus natural log q to the 1/2. So it's like, or I could do this much. And then by property 3, I'm going to be right down here. Okay, so you know, play around with that. Make sure you see how those two methods work. But this is the expanded one. Now we're going to go in the opposite direction. We're going to combine logarithmic expressions. So instead I'm going to give you this expression in the box, and you're going to come back with this. Writing this logarithmic expression as a logarithm of a single quantity, this is a single quantity, with a coefficient outside here of 1. You don't want to have like 2 times the natural log of stuff, because by property 3 I can bring that up as an exponent. So we're going in the opposite direction. And this is actually a skill that we will need in our work in solving some logarithmic equations. All right, let's take a look at this. So notice I have an expression involving what? Log base 5, so our base is 5. Log base 5 of this quantity plus log base 5 of this quantity minus log base 5 of that quantity. So I'm going to start with these two. Notice the addition I can combine by property number 1. If we go back to property number 1, I'm sort of going in reverse now. I'm looking at a sum of logarithms, and I'm going to condense it down to the logarithm of a single quantity. So, right, if I have a log of something, x minus 3, plus log of something else, x, it becomes what? The log of the product of those two things. So by property number 1 here, going in reverse, this becomes log base 5 of what? X minus 3 times x. And if we want to, we can go ahead and multiply this by distributing the x through. And I get x squared minus 3x. Minus log base 5 of what? X plus 2. Okay. So now I've got log base 5 of this minus log base 5 of this. So what's that? That's property 2. I can combine that as a single logarithm, right, as a quotient of those two things. So that's what I'm going to do by property number 2. This would be log base 5 of this up top, which is I've written as x squared minus 3x, divided by log of x plus 2. Okay. And notice that's a single logarithm, right? Log of a minus log of b is log of a divided by b. That's what we're making use of in this second property here. And now I have a logarithm of a single quantity. This is one quantity. It's pretty complicated. I've got to, do some work here for a given value of x, but it's a logarithm of a single quantity. Okay. Let's look at one more. All right. So first of all, here I've got 3 times log of x minus log of y plus 1/2 log of z. So what I'm going to do is I'm going to make use of property 3. And again, there's a couple ways I can go with this, but I'm going to do property 3 first and write this as natural log of x cubed, right? So that was property 3 going in reverse. So I have a multiple of a logarithm. I can bring that exponent, or that coefficient n up as an exponent on x. And that's what I've done, right? The n is 3 here. And so it becomes x to the n. Natural log of x to the n, in this case, is x cubed. So it's log of that minus log of y. And then the 1/2 I'll come up as what? Plus natural log of z to the 1/2 power. Now, z to the 1/2 power, what do we usually write that as? That's the same as what? The square root of z. Okay, so I'm just going to replace that with square root of z. Okay. Now, notice these two I can combine by number 2, right? The log of a minus the log of b is what? This is going to be the log of x cubed divided by y, right? Plus what? Natural log of the square root of z. Okay, so again, the difference of logarithm becomes the log of a quotient. And then finally, log of this whole thing plus log of this thing, adding, that's property number 1. I can write the sum of logs as the log of a product. So natural log of x cubed over y times the square root of z. Right? But we can write this, of course, square root of z over 1. I can write this a little more compactly as x cubed square root of z up top all over y. And there's our answer, condensed. Natural log of a single quantity. Natural log of a single quantity. Okay, so that's the main skill that we're talking about, expanding and condensing logarithms. There's lots of other things we can do. I do want you to be careful, though, about some mistakes, and that is these come into play. So log base a of x plus y is not, like I said, you can't just distribute this through and say this. Again, this is not log base a times x plus y. It's not like 2 times x plus y, which would be 2x plus 2y. This is log base a of, right? This is the name of a function. So it says plug x plus y into the logarithmic function. In fact, log base a of x plus log base a of y we know is what? This is log base a of x times y. That's the property of logarithms. Log of a product is the sum of logarithms. So obviously these two are not the same. Right? Another incorrect assumption is log base 7 divided by log base 3 is equal to log of 7 divided by 3. That is not the same thing. Again, it's kind of like distributing log 7, log 3. You can't do something like that. In fact, log of 7/3 is the log of 7 minus log of 3. Right? And again, be real careful here. Log of 5, that whole thing to the 8th power is not 8 times log of 5. 8 times log of 5 is the log of 5 to the 8th power. Do you see the difference between these two? Here I take 5 to the 8th power, then take the log of it. Here I'm taking log of 5 and then raising that to the 8th power. So be careful. We can only bring the power down when it's on this thing we're taking the log of. Okay, log of 5 to the 8th power, we can bring the power down. So these are common mistakes, so definitely review those. I want to close this section out then with a change of base formula. And this is real important because, for instance, when you're, if you're doing calculations on some calculators, there is not a key for any log base. There's only a key for log, which is what, base 10, and ln, which is base e. There's not a log base 2 or log base 3, etc., etc. Some calculators have it, but others do not. Either way, even the ones that have it, how do they do that? Well, there's this change of base formula. I'm not going to prove it to you, but this is true. For log base b, for any base, I can evaluate that by choosing another base like a. Okay, notice this is log base a, log base a. So log base b of x is log base a of x divided by log base a of b, right? The base you're changing from b, right? Take the log you're changing to base a of that. Basically divide log base a of x. And so another way of thinking about this is 1 over log base a of b times log base a of x. And this right here is, constant depending on your values of a and b. And so log base b of x is just a constant multiple of log base a of x. And if you remember, multiplying a function by a constant is a vertical stretch or shrink depending upon that constant. And so what this really is saying that any log function of one base, the graph is related to the log of any other base by just a vertical stretch or shrink. And they all look the same, they're just vertically stretched or shrunk depending on the situation. Or this could be a negative constant too, so I guess we could also have a reflection in the x-axis. And if you look at the graphs that we looked at in the last video of the logarithmic functions, that will make sense. Now, what do we typically desire a to be? Well, typically 10 or e, simply because our calculator has those bases, right? Log base 10, right? ln log base e. So we can now estimate the value of any logarithmic function as well as graph it on our calculator. So for example, if I want to graph log base 3 of x, what's that? Well, if I choose base 10, it's log of x, right? Log base 10 of x over log base 10 of 3, right? Which I can write this way. So I can graph using my calculator with that. Or I can use log base 3 of x as what? Natural log of x over natural log of 3. Right? So for instance, if I wanted to calculate what is log base 3 of 15. Well, that's the power of 3 needed to get 15. 3 to what power equals 15? Well, 3 squared is 9. 3 cubed is 27. So it must be some power between 2 and 3. I don't know what it is. Well, again, if I don't have a log base 3 button on my calculator, I can't even calculate that. or approximate that rather. But I can use either the common logarithm, log base 10 of 15 divided by log base 10 of the base that I'm changing from, 3. It's also equal to log base e of 15 over log base e of 3. And let's just show you what that is here in both cases. Change the contrast down a little bit so we can see the screen a little bit better. Okay, so log of 15 divided by log of 3. All right, gives you that number. Let me just show you natural log of 15 divided by natural log of 3 gives you that same quantity, the same thing, same expression. But if I take 3 and I raise it to that power, and I'm just going to use the answer key, right? Answer has this value of this exponent. Guess what I'm going to get? 15. It's the power of 3 needed to get 15. Okay, so that's a real cool tool to help approximate, especially if you don't have a log base 3 button. You can use the change of base formula. Change of base formula, again, nice little thing to have. Okay, we will stop here, and in the next videos we are going to be looking at solving logarithmic and exponential equations. That's going to be a lot of fun.